Hello, in this lecture we will find the radius of the circle enclosed in a triangle. In the drawing you can see triangle ABC. Side AB of the triangle equals to 4 units, side BC equals to 3 units, and side AC of triangle ABC equals to 5 units. And we also know that the area of triangle ABC equals to 6 units squared. And we want to find the radius of the circle inside the triangle. Okay, so first of all, let's call the center of this circle O. So point O is the center of this circle, and let's call the touching point between side AB of the triangle to the circle N. Again, point N is the point of contact between the circle and side AB of triangle ABC. Okay, and let's call the touching point between side BC of the triangle to the circle M. Again, point M is the touching point between side BC of the triangle to the circle. Okay, and let's call the touching point between side AC of the triangle to the circle P. Again, point P is the touching point between side AC of the triangle to the circle. Okay, N is the touching point between side AB of the triangle to the circle, and M is the touching point between side BC of the triangle to the circle. Okay, now let's connect points O and M together by a straight line. So actually line segment MO is the radius of this circle. I will mark it as small r because it starts from the center of the circle and ends at point M. That is a point on the circle itself. For that reason, it is defined as the radius of this circle, because the definition of a radius of any circle is a line segment that is inside the circle and starts from the center of the circle and ends at any point on the circle itself. And line segment MO starts from the center of the circle, that is to say point O, and ends at point M, that is a point on the circle itself. For that reason, MO is the radius of this circle. Okay, and then we will connect together points O and N by a straight line. And actually line segment NO is also the radius of this circle, because it starts from the center of the circle and ends at point N, that is a point on the circle itself. For that reason, line segment NO is the radius of this circle. And in the same way, we'll connect points O and P together by a straight line. And again, line segment OP is the radius of this circle, because it starts from the center of the circle and ends at point P, that is the point on the circle itself. For that reason, line segment OP is the radius of this circle. I will mark it as small r, and also ON or NO is also the radius of this circle. All the radiuses starts from the point that is the center of the circle and ends at a point that is on the circle itself. For that reason, all the line segments are the radiuses of this circle. Okay, in the next step, we will connect together by a straight line points O and C. And in the same way, we'll connect together points O and B. I will repeat on what I said in the start of the lecture, that point side BC of the triangle is tangent to the circle and to the radius at point M. Side AB of the triangle is tangent to the circle at point N, and side AC of the triangle is tangent to the circle at point P. Okay, so actually we have a rule. I will call it rule number 1. And rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So I will read the rule number 1 again. In any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius R is perpendicular to the tangent, to its tangent. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so actually we can implement this rule number 1, in our circle, because actually we have radius and we have tangent to that radius. As I have already told you, side BC of the triangle is tangent to the radius at point M. For that reason, according to rule number 1, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. And we can say that also radius, the line segment OP, that is the radius, we have side AP, side AC, that tangent to the circle and to the radius also at point P. So we have radius and the tangent to that radius. According to rule number 1, angle OPC will be equal to 90 degrees, and also angle OPA will be equal to 90 degrees. Okay, because the radius is perpendicular to its tangent. That is to say, angle OPC equals to 90 degrees, and also angle OPA equals to 90 degrees. And in the same way, we have radius, actually ON, line segment ON is the radius of this circle, and we have tangent to that radius. Actually, side AB of the triangle is tangent to the radius, to the circle, and also to the radius at point N. For that reason, according to rule number 1, angle ONB will be equal to 90 degrees, and also angle ONA will be equal to 90 degrees. Okay? According to the rule that in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay? We have here 3 radiuses and 3 tangent to that radiuses, and they create between them 90 degrees. Okay, so this angle 90 degrees, and this angle is 90 degrees, 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 also this angle is 90 degrees, because in any circle the radius is perpendicular to each tangent. This is the radius and this is the tangent. For this reason, this angle is 90 degrees and this angle is 90 degrees. Okay, in the same way you can say about this radius and it's perpendicular. This angle is 90 degrees and this angle is 90 degrees, and we can say the same way about the radius and its tangent, that this angle is 90 degrees and this angle is also 90 degrees. Okay, so actually in the next step we will focus on triangle BOC. Actually it will be the green triangle. As you already know, the area of any triangle equals to the base of the triangle times the height to the base of the triangle times the height to the base divided by 2. Okay, it is true for all the triangles. The area of any triangle equals to the base times the height to the base divided by 2. Okay, the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Okay, or we can say instead the area, I will write A, it is the abbreviation for area. So A equals to the base times the height to the base divided by 2. Okay, the area of any triangle A equals to the base times the height to the base divided by 2. Okay, so actually in the green triangle, the area in the green triangle of triangle BOC, the area of triangle BOC will be equal to the base of the triangle that equals to 3, according to what is given us in the question, times the height to the base. The height, this is the height because it makes 90 degrees with the base. The height always make 90 degrees with the base. Here is 90 degrees and here is 90 degrees. So the radius of this circle is actually the height of triangle BOC, all divided by 2. The height of this triangle is the radius of the yellow circle because it makes 90 degrees with the base, that is 3 units. So 3 times the radius divided by 2 is the area of the green triangle, of triangle BOC. Okay, but 3 over 2 is 1.5. Yes, 1.5 are units. Okay, well, okay, so the area of the green triangle equals to the base of the triangle times the height, that is 3, times the height of the triangle, that is R. The radius is the height of the triangle, so 3 times the radius of the circle divided by 2. 3 over 2 is 1.5, so we got that the area of the green triangle equals to 1.5 r units squared. Okay, so the area of the green triangle equals to 1.5 units squared. Okay, in the same way we will okay, in the next step we will connect together points O and A by a straight line. Okay, we connected points O and A together by a straight line, and actually we will focus on triangle AOC, or the yellow triangle. So the area of the yellow triangle AOC, the area of the yellow triangle AOC will be equal to the base of the triangle that equals to 5 units times the height to the base. It makes 90 degrees. The height makes 90 degrees with the base. So the radius is the height of triangle AOC, of the yellow triangle. So it is 5 times the radius divided by 2. Okay, the area of the yellow triangle equals to the base of the triangle times the height of the triangle, that is the radius of the triangle, divided by 2. Or 5 times r divided by 2. 5 over 2 is 2.5. So it is actually 2.5 r. Okay, r units squared. So the area of the yellow triangle equals to 2.5 units squared, because 5 over 2 is 2.5 times r, so it is 2.5 times r units squared. Okay, this is the area of the yellow triangle. And at the last we will calculate the area of the orange triangle. So the area of any triangle equals to the base times the height to the base divided by 2. The base of the orange triangle equals to 4 units. Area of triangle AOB equals to the base of the triangle, that is 4, times the height to the base. The height always makes 90 units with the base, so the radius makes 90 units with the base. So the radius is the height of the orange triangle, so it is 4 times the radius of the circle divided by 2. Okay, so actually the area of the orange triangle equals to the base of the triangle, that is 4, times the height, that is the radius, divided by 2. 4 over 2 is 2, so we will get that the area of the orange triangle equals to 2 times r. Units squared. Okay, so the area of the orange triangle equals to 2 times r units squared. Okay, but actually the area of triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay, so it is sum of the areas of the green triangle, triangle BOC, plus the area of the yellow triangle, that is triangle AOC, plus the area of the orange triangle, that is triangle AOB. Okay, it is very simple. The area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay, so I created equation number 1 that says that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, but we know that the area of the big triangle ABC equals to 6 units square, so we can substitute the area of ABC by 6. And we know that the area of the green triangle, triangle BOC, equals to 1.5 units. So instead of the area of the triangle BOC, we can write down 1.5 r unit square, because the area of triangle BOC equals to 1.5 units square, 1.5 r units square. So instead of triangle area of triangle BOC, we can write down 1.5 r unit square, because the area of triangle BOC equals to 1.5 r unit square. Okay, triangle, yes. Okay, plus the area of the yellow triangle, that is triangle AOC, equals to 2.5 r unit square. So we can substitute the area of triangle AOC in the first equation by 2.5 r unit square, because this equals to this. Okay, so 2.5 r plus the area of the orange triangle equals AOB equals to 2 times r unit square. So instead of the area of AOB, we can write down 2 times r, because this equals to this. Okay, I will repeat again. The area of the big triangle ABC is given to us in the question, and we know that the area of the big triangle ABC equals to 6 units square, and the area of triangle BOC, the green triangle, equals to 1.5 r unit square. So we can substitute the area of triangle BOC by 1.5 r, because the area of triangle BOC equals to 1.r unit square. And we can substitute the area of the yellow triangle, triangle AOC, by 2.5 r, because the area of the yellow triangle AOC equals to 2.5 r. Okay, so we can substitute the area of the yellow triangle AOC by 2.5 r, because 2.5 r equals to the area of the yellow triangle. And then we substituted the area of the green of the orange triangle, triangle AOB, by 2r, because the area of the yellow triangle equals to 2 times r unit square. Okay, so in total we got that 6 equals to 1.5r plus 2.5r plus 2 times r. 1.5r plus 2.5r equals to 4r, and 4r plus 2r equals to 6r. So in total we got that 6 equals to 6r. Okay, 6 equals to 6r. We will divide the equation by 6. We got that the radius of the circle after we divided the equation, we got that the radius of the circle equals to 1 unit. Okay, so the answer to the question is that the radius of this circle that is inside the triangle is 1 unit. Okay, so that is the answer to the question. Okay, thank you very much.